Hello everyone, my name is Arman and we would like to study applications of sinusoidal functions today. So it's a topic of Math 11. Uh, so we would like to know when we can use this model in real life and look at some applications. Uh, so please feel free to uh, ask your questions or stop me at any moment if you have any doubts. Uh, So we would like to think about the phenomenon or uh, patterns where there is some uh, event that is repeating itself. Uh, so if you think about events or patterns that are repeating themselves, we can think about, for example, waves or tides that go in and out. Um, or we can think about even a heartbeat. The heartbeat has a rhythm. Or, for example, when you are riding a Ferris wheel and you go up and down in a certain pattern and it's repeating itself again. So these are all examples where an event is repeating itself. So when you want to create a mathematical model for this type of phenomenon, we naturally think about sine and cosine functions because they also repeat themselves. If we think about the graphs of sine and cosine, for example, so we know that the graph of sine function, so if we think about the graph, so the graph looks like this. And this point here is 2 pi. So we can see from the graph that at every 2 pi, the graph again repeats itself. So it has a peak here or maximum and a minimum here. And then at 2 pi, we are back to the original place. And then the graph repeats itself. So similarly for cosine function, so this was what I called sine x. Similarly, for cosine function, it repeats itself again. So again, at 2 pi, the function repeats itself. This is what I call cosine x. Well, so the idea is to use these functions to create model for the phenomenon that are repeating themselves and follow a certain rhythm or pattern. But we need some modifications, of course. For example, as you can see, sine x, so starts from 0. Cosine starts from maximum, which is 1. But in real life, maybe the maximum is not 1. For example, the Ferris wheel goes in and up and down. The maximum height, of course, may not be 1 meter, for example. So in those cases, we have to do some modification, or maybe it doesn't start from maximum because right now for cosine x, if we think about the horizontal axis or x-axis as time, so it has maximum at x equals 0 or at t equals 0. But maybe in real life, the phenomenon that we want to create a model for it, maybe at the beginning of the time, it's not at its maximum. Maybe it reaches its maximum at some point later. And at t equals 0, it may not be at the maximum, it may not be at 0. So in those cases, we should not use sine and cosine in the form that I wrote here. We need some modifications. So in general, for sinusoidal functions, so sinusoidal functions, which can be used um, for phenomenon that repeat themselves. We have the general form of y equals a times sine, let's say b times x minus c plus d, or y equals a times cosine b times x minus c plus d. So these are the general forms of the functions that you can use to create models for phenomena that repeat themselves. So as you can see, we used sine and cosine functions, but with some modifications in the sense that, for example, we multiplied with some constant or added with a constant or multiplied the input or the angle again with a constant. So I'll explain how to determine these constants or how these constants will affect our model. So let's start with uh, the first parameter or first constant, which I denoted with A. So we can say, talk about here about interpretation of constants above. So let's start with A. A is called the domain. And what's the role of this domain? So the role of the domain is that it measures the distance from the midpoint or from the average. So it measures the distance from the average. So for example, let's say the minimum and maximum height of tide when you are next to a beach, for example. If the minimum and maximum heights are 1 and 5 meters, for example, so then in average between 1 and 5 is 3. So then distance from 3 is called the domain. So if I want to create a formula about how to find this constant domain, so the way we can calculate it is that we can look at the minimum and maximum values and the difference between them. So see in the case of 1 and 5, when the minimum was 1 meter and maximum was 5 meter. So the way we calculated the domain was that we could say the difference between these two. So the difference is 5 minus 1, which is 4. And half of this difference will determine the domain. Difference over 2 will be the domain. So we can say the formula for domain A, is A equals maximum minus minimum divided by 2. Because half of the difference between maximum and minimum shows the distance that the function takes from its average. Again, in the case of, for example, 1 meter minimum height of the tide and 5 meter maximum height of the tide, the average is 3, uh, and therefore the distance between 3 and 1 or 5 is 2. And that 2 is the domain. So this is how we can calculate or define the domain. And then we also talked about the average value when there is minimum and maximum and there is some average. So that average will be denoted by D. So this constant D here, whether you look at here or here, this constant D represents the average, or also called midline. So next parameter is D, called midline, is the average between minimum and maximum values. So D equals maximum plus minimum divided by 2. And then B, the constant B that you can see here, this determines the period. The period means the time interval that the phenomenon repeats itself. So for example, the example of waves and tide in the ocean, maybe it repeats itself every 12 hours. So then period is 12 hours. In the case of heartbeat, the heartbeat repeats itself maybe every 2 seconds or every 1 second. Then the period is 1 second. And what is the relation between B, the constant B, and the period? So B is not the period itself, but it determines the period. Now, what is the relation? So B determines the period, the time interval. Period means the time interval that the phenomenon repeats itself. So we calculate B as, sorry, the period T, the period, we calculate it as 2 pi over B. So if we have the period, we can determine the constant B and vice versa, because we know the relation or the connection between them, how they are related to each other. And C is the horizontal shift. This constant C that you can see here is horizontal shift, which will be necessary to determine at which x value the function takes its maximum or minimum value. For example, the model that we previously talked about, A times cosine B times x minus c plus d, takes its maximum value at x equals c. If you look at the graph of cosine, it takes its maximum value at 0. This is the maximum value. It takes the maximum value at 0. So that means the input for cosine has to be 0 in order to have a maximum value for cosine. The input of cosine. But now the input in our model, if you look at the input, look at the input here, b times x minus c. We know that if the input is if the input is 0, the function takes its maximum value. Now, when can I say that this input is 0? Look at this expression, b times x minus c. When will it be 0? Well, I'm assuming that B is non-zero. So if this expression wants to be zero, if the product of two numbers is zero, one of them I already know it's non-zero. So that means the other second number must be zero. And x minus c will be zero if x equals c. So that's why I'm saying that at x equals c, the input for this cosine function becomes zero, and the overall function takes its maximum value. So again, in the example of tide in the beach, so for example, if the maximum height reaches at, for example, 5 p.m., so that means you can set your C to be 5. So I explained how these parameters determine our model, and I briefly talked about the example of uh, tides and going in and out a few times. So now I would like to uh, write this as an example, and write a formal solution for it to see how we can create a model for tides in the beach going in and out, and how to use that model to determine the height of tide at any moment. So I'm talking about tides going in and out, but again, you can replace tides with any other examples. For example, Ferris wheel going up or down. As long as you have minimum and maximum and the phenomenon repeats itself, you can again use the same model and use these parameters to determine how how to create the model for your phenomenon. So let's write down the example for tide. So example, consider tides going uh, in and out at a beach or at an ocean uh, with minimum height of uh, let's say for example 1 meter at 2 p.m., maximum of 5 meter at 6 p.m. And based on this information, we want to create a model for tides at this ocean. So create a sinusoidal uh, model and predict uh, the tide height at 7 p.m. So let's analyze what information is given to us and what are we supposed to do. So we know that the minimum height is 1 meter, maximum height is 5 meters. So if we have the minimum and maximum values of the function, we previously saw how to determine the domain and also how to determine the midline. So two of the parameters can be already determined just using minimum and maximum values of the function. So if you go back, see, we explained about the parameters A, B, C, and D. We said that A is maximum minus minimum divided by 2, and D is the average, maximum plus minimum divided by 2. So D is called the midline, A is called the domain. So let's first determine these. So first, determine uh, A, which is domain, and D, which is midline, as follows. So A equals uh, maximum minus minimum divided by 2. So this is going to be 5 minus 1 divided by 2, or 2. And D was the average, maximum plus minimum divided by 2. 5 plus 1 divided by 2, or 3. So if you think about it, uh, the average value is 3 because minimum 1 and maximum 5. So average is 3. So you go 2 units above the average, or 2 meters above the average to reach the maximum, and 2 units or 2 meters below the average to reach the minimum. This distance that you go above the average to reach maximum, below the average to reach minimum, is called domain. So again, 2 meters above this is the maximum. Domain plus midline, in other words, is the maximum. And midline minus domain, or 3 minus 2, will be the minimum. Now, what else can we determine? We can also determine B. B was related to the period, if you remember. What was the relation between the period and B? The relation was, the period was 2 pi over B. So is the period given to us here? So the period is not directly given, but the time between minimum and maximum is given. So let's look at the graph one more time. See if we know the distance, or the x value, the horizontal distance between minimum and maximum. Look at here, between maximum and minimum. This distance is half of the total period, because you go from maximum to minimum, then again from minimum to maximum, and then again it repeats itself. So if we know the distance between minimum and maximum, or distance between maximum and minimum, each of these will be half of the total period. Same thing in this graph. See, from minimum to maximum, or from maximum to minimum, each of these are half of the total period. So for sinusoidal function, you go from minimum to maximum in half of the period, and then maximum to minimum, again, half of the period, and then the phenomenon will be repeating itself. So here, let's go back to our example. Minimum at 2 p.m., maximum at 6 p.m. So from minimum to maximum is 4 hours. This 4 hours is half of the total period. So that means the total period is 8 hours. So we can say the period, or T, is 2 times the time between min to max. And this is 4 hours. So this is 8 hours. And we know that T is 2 pi over B. So this was the relation between T and B. So that means 8 is 2 pi over B. B will be 2 pi over 8, or pi over 4. So we found here, we found B. And how about C? So we previously saw that the maximum value will be taken at x equals C. The maximum, here our x is T, the time. The input is time, and the output is the height. So here the x value represents the time or t, and the y value is representing the height. So here the height will be taken at which t value? If you look at the question again, the maximum height is taken at t equals 6, at 6 p.m. So my start of the time, or t equals 0, basically here is 12 p.m. So we can also mention this. So let's take t equals 0 at 12 p.m. Then max occurs at 6 p.m., which means t equals 6. If 12 p.m. is t equals 0, then 6 p.m. will be t equals 6 in hours. The unit of time here is in hours. So we know for y equals a times cosine bx minus c plus d, the max occurs at x equals 6. So at x equals c. Now, if we compare these two, on one hand should occur at x equals c or t equals c. Here my x is t, so we can replace this x with t, because in our example, the input is time, so we can represent it with t. So this maximum occurs at t equals c, but in our example, it occurs at t equals 6. So in the general model, it occurs at t equals c, the maximum value here at t equals 6. So if we compare these two, we can obviously see that the value of c must be 6. So by comparing, so let me call this one maybe star, and this one double star, star and double star. We conclude that c must be 6. So we found all the parameters. We found A, the domain, B, which was related to a period, C, which was related to the horizontal shift and where the maximum occurred, and D, the midline. We determined all the parameters. Therefore, we have our function. So our function will be, which will representing the height of tides at any t value, at any time, is y equals a was 2 cosine, b was pi over 4, x minus 6, plus d was 3. I use t because it's height versus time, so we can use the input as t. So see, this is a function. We know every function has inputs and outputs. The input is t, the input is t or time, the output is y or the height. So at any t value, we know the height. At t equals 6, we know that it must be the maximum height, which is 5 meters. Let's check. If you replace t with 6 here, this becomes 0. Cos 0 is 1. 1 times 2 is 2, plus 3 is 5. So at t equals 6, the height is 5, as we expected, because this information was given to us in the question. Or at t equals 2, you can check. At t equals 2 p.m., how much was the height? The height was 1 meter. Let's check. At t equals 2, 2 minus, if you replace t with 2, 2 minus 6 is minus 4. So let's check. So see, let's check. at t equals 2, y will be 2 times cosine pi over 4. 2 minus 6 is minus 4 plus 3. This is 2 times cosine 4. Uh, pi over 4 times minus 4 is minus pi. Minus pi plus 3. Cosine minus pi is minus 1. So 2 times minus 1 plus 3, which is 1. It's 3 minus 2, which is 1. So our model is consistent with the information that's given to us. At t equals 2, at 2 p.m., 1 meter high, and at t equals 6 p.m., 5 meter high. So this is the model. We created the model. Now we can use this model to extract any information. For example, it was asked, what is the height at t equals 7 p.m. or at t equals 7 hours? At 7 p.m., which will be t equals 7 hours. So at 7 p.m. or t equals 7, the height will be, how do I find the height? I know what the height is as a function of time. Once I have time t, I can easily find the height. I know that the time is 7 hours. T is 7 hours. The time is 7 p.m. So I replace t with 7 into the function, plug into the function, find the y value. The y value will represent the height. So the height will be y equals 2 times cosine pi over 4 times 7 minus 6 plus 3. So this is 2 times cosine pi over 4. 7 minus 6 is 1. So cosine pi over 4 plus 3. Cosine pi over 4 is 1 over root 2 or root 2 over 2 plus 3. So the answer becomes root 2 plus 3. And the unit was meter. So the height of tides is root 2 plus 3 meter at 7 p.m. So what we saw today, we have different phenomenon in real life, in nature, where something is repeating itself. It can be tides going in or out, or Ferris wheel going up or down, or the heartbeat, the rhythm of heartbeat um, beating over and over. And as long as we have this pattern and the phenomenon repeating itself, we can use sinusoidal form. The general form was A times sine here. A times sine B times sine B times x minus c plus d, or A times cosine B times x minus c plus d. Each of these parameters can be determined based on minimum and maximum values and how long it takes for the phenomenon to repeat itself and when the maximum occurs. Once we determine these parameters, we have a model. We have a model for our phenomenon, and we can determine the output. The output, for example, in the example of tides, was height. The input was time. Similarly, for the Ferris wheel going up or down, again, the output can be height and the input can be time. So we looked at the examples of tides going in and out, and we created the model, and based on that model, we predicted the height of the tide at 7 p.m. And one exercise I would like to give you so that you think about it, and that's about, again, the heartbeat that I mentioned earlier. Uh, so maybe I've seen that when people want to test for their heart health, they use ECG. So ECG measures the electric voltage produced by a heart in each heartbeat, and it follows a sinusoid, almost a sinusoidal form, and it's uh, uh, it's not exactly sine function, but it's repeating itself, and it can be approximated by sinusoidal function. And the ECG, if you have seen it, ECG, the pattern looks like a sine or cosine function. It it has a maximum and minimum, and it's repeating itself. So let's look at an example related to uh, ECG and the heartbeat. So exercise, a person's heartbeat produces an electrical signal that repeats in a regular cycle. Suppose the ECG voltage uh, oscillates between minus 1.2 millivolts and 1.2 millivolts. And the heart completes one full cycle. One full cycle in every 0.8 seconds. Write a sinusoidal model for v of t. So here again, remember in each sinusoidal function or model, we have input and output. Here, the input is again time. We are looking at how the electric voltage is changing as a function of time. As time passes, how is the voltage changing? Going up and down, repeating itself. And the output at every time, at every t, we are looking at the voltage, electric voltage produced by the heart. So the output is the voltage, I denoted with V. The input is time, denoted with T. So what we need here is a model, sinusoidal model for V of T, voltage as a function of time. So I want to write a sinusoidal function or model for V of T. And we also want to know, so that's part A, and part B, at what time does the voltage reach its maximum value? And at what time does the voltage reach its minimum value? See, it is given in the question that the maximum voltage is 1.2. The maximum voltage is 1.2 millivolts and minimum voltage is minus 1.2 millivolts. But it doesn't say at what time it happens. In other words, the outputs, the voltages are given, but the inputs or times for which those outputs happen are not given. So here we want to know the model, and then once you write the model, you can use that model to determine at what t the maximum occurs or the minimum occurs. So in the previous example, we had the time and we determined the output. This time the output is given. For example, we know that the maximum output is 1.2. So the output is given in part B, and you want to know the time t. And similarly in part C, again, the output is given, which is the minimum value or minus 1.2, and the time or t is asked. So please try to solve this question, and uh, you can send me your solution and I can um, check it for you. Uh, thank you. Thank you for uh, attending and listening to this lecture about sinusoidal functions and its applications. Thank you and have a good day.